All right, what's up, guys? Welcome to the channel. If this is your first time here, make sure to drop a like and then make a comment. I don't know what I'm doing. Oh, anyway. This is your second AMI day in a row. Woo! So I read through the responses on AMI day one already, and I think a majority of us want to get some practice with some radical stuff, simplifying them and stuff. And we are going to hit the ground running on Thursday with we hopefully it's not a wood, but that's book. Um, get back. So I picked out three different questions I want to go through. Now for your AMI assignment, you're going to need to fill out a Google form I post. It's just going to say answer to question one and answer to question two. I'm going to pose two random questions throughout the video, and they're random. So that means that you actually have to watch it. Oh, how dare I? I know, how mean. So, and I'll prompt you at that very specific moment. However, this is going to be a nice little review for refreshing on radicals, on how to simplify them down, especially when you have them in the denominator. Now it says rationalize the denominators. What does that even mean? Well, denominator means divide, or the bottom part of your fraction, right? You can't have any radicals down there. That's like one of the no-nos in math. So that's not going to be the simplified form as well. So example one, you have 12 root 160 divided by 2 root 5. There are multiple ways to approach this, but we're going to jump right in with the straightforward way here. So what do you want to do? Well, if you have a number next to a radical, that's multiplication. And since it's all division, those two are kind of inverse operations, you can kind of, there's some more nuance to it, simplify it down by splitting up the fraction. So you got 12 divided by 2 now, and then times, and then root 160 over root 5. That's something you can do. It's a valid math thing. And then you have radical over radical without any addition or subtraction inside, of course. You can actually break it down into one radical now. So, meaning that this part can just be 160 over 5 square rooted. That is also valid. Alternatively, you could break down the radical first. Root 160 has an obvious perfect square that goes into it. Hint, hint. And then, now we just keep going. So 12 divided by 2 is obviously 6. No calculator needed. And 160 over 5, if you're clever, you can lump it root 32. And then we can break down root 32, right? Just like we did for like an entire month last semester. So you got 6 times, and then root 32 can be broken up into root 16 and root 2. So then you got root 16 is 4. Then you got root 2. So then you got, final answer, 24 square root 2. Alternatively, you could have broken down root 160 right from the get-go in 16 and 10. And you would have gotten the exact same answer if you went the whole route there. Now, question one on your Google form is the following. Which is the worst day of the week, in your opinion, and why? Make sure you put the why there. You can't just say, oh, I hate Tuesdays. No, you gotta be more specific as to why you would hate a Tuesday. I personally think Tuesdays are at least B tier, so don't at me. Now, you guys ready for example two? Well, you got 3 root 12 divided by 4 root 7. Now, the astute individual would recognize that we can't go the same way that we just did, because the square or 12 over 7 isn't a nice clean number, is it? No. So therefore, you got to go with an alternate approach. First, you could break down root 12 because a perfect square does go into root 12, and it actually makes it a little bit easier to work with. So let's break down root 12. So you got 3, and then root 12 can be a perfect square that goes into 12 is 4. Don't break it down into 6 and 2 because 6 nor 2 are perfect squares. So you got root 4, root 3, because 4 times 3 is 12. So then you got 6 root 3 up top now, because the square root of 4 is 2, and 3 times 2 is 6, over 4 root 7. Oh, I should have changed colors because this is going to get confusing. Hang on a second. There we go. All right. So now we're here. 6 root 3 over 4 root 7. Here's a key thing you want to do here. You want to multiply the top and the bottom by 1, of course, because this is not an equation. This is an expression. So you can't change equality. But the fancy form of 1 that we're going to choose is root 7 over root 7. Multiply top and bottom by root 7 over root 7. So then you got 6 and then square root 21, because 7 times 3 is 21 now. Divided by, and then 4 times root 7 times root 7. Square root of 7 times square root of 7 is square root of 49. Or the square root of 49 ends up just being 7. So then you got 4 times 7 on the bottom, because root 7 times root 7 is just 7. Or root 49, which just ends up being 7 anyway. So then you break it down even more. So then you got 6 root 21 over 28, which we can obviously break down into 3 square root 21 divided by 14. Why was that so hard? Final answer. Woo! Now we did something similar with this back when we were talking about imaginary numbers, right? Well, want to know something crazy? It'll blow your mind. This last question is just like it, I argue. Now, there's a nice little vocab word that we use for this specific circumstance. If you just multiply by root 6 on top and bottom, it's not going to end up working out. So you got to be clever. 1, we don't want any radicals in the denominator. But one big thing is we have a binomial now. Before you just had a monomial, meaning that you didn't have addition and subtraction on the bottom. Now we do. What are we ever going to do? Well, you have to multiply the top and bottom by 1 once again. But now let me change colors once again, so that way it doesn't get confusing. But it also has to pop as well. So because chalkboards are kind of specific like that. Let me rewrite this. 8 minus root 6 divided by 3 minus 4 root 6. Now, does anyone know what we'd have to multiply the top and bottom by? Pause the video for a second if you really want to for the dramatic effect. All right, cool. Let's try. Yes, that's exactly correct. You multiply it by the conjugate. Whoa, vocab terminology here. Oh, God, I just did it wrong. You multiply it by the conjugate at the bottom. Not the complex conjugate, because we're not working with complex numbers. But I argue that this is the same thing. So 3 plus 4 root 6 over 3 plus 4 root 6. Now, what came first, the chicken or the egg, right? That's what you're probably asking yourself. What do you mean, Mazzola? Well, what came first, the imaginary complex conjugate, the complex one, or the radical conjugate? Well, I argue that this is going to be question 2. Question 2 for you is, which came first, the complex conjugate or the radical conjugate, and why? Leave your comments. No, not actually in the comment section, but you should totally like, comment, and subscribe to get my ratings up. If we get 100 likes by the end of the semester, I might bring in pizza. I don't know. We'll try it out. Don't quote me on that. Depends on the vibes. But let's finish it. So now, we actually got to multiply the bottom and the top. Now, of course, multiplying a binomial by a binomial, we do this thing called a FOIL. Whoa, that's an acronym, right? So let's see. So you got 24, and then you got plus 32 root 6 minus 3 root 6, and then minus 4 times root 6 is root 36 or 6. That's top. And on the bottom now, we end up getting, well, first order, inner last. We got 9, and then you got plus 12 root 6 minus 12 root 6. That just cancels out. What a coincidence. Oh my gosh. And then you got minus 16 times root 6, so 6 on the bottom. Okay. So now let's clean it up. You got 24 minus 24. Oh, wow. So now you got 29 root 6 on top. So that cancels. Um, Sorry, my handwriting is kind of meh. It's hard writing on that chalkboard while you're kneeling, while you're also trying not to get in the way. It's kind of the thing. And on the bottom, you got 9 minus 16 times 6 is 72. So negative 63. Yeah, and that's it. You can't really break it down anymore either. It's kind of underwhelming answer. Shoot, I thought that was a better answer. Well, anyway. Make sure you stay warm. Email me if you have any questions. Make sure to like, comment, subscribe. Thanks for staying for the whole video. It really means a lot to me. You guys are just my fans, and all right, whatever. I'll see you Thursday.